Okay, guys, we're in Algebra 2, Mod 8. Today, Monday, April 20th. Hope you had a great weekend. We're going to continue on with our conic section chapter. Really only two more things to do. One thing that we're going to do today, so again, taking your notes, just like you're supposed to. Hope you're keeping a nice, neat notebook to carry forward with you in the next year. Top left corner. Again, today is Monday, 4/20/20 is the date. The title says Mixture of Conics. And what they always have us do at the end of this unit is kind of mix up all four types of conic sections and throw them together in the same day. It makes sense to do that. If you remember, we took it one day at a time and did a different picture each day. I'll remind you, we did circles, then we did ellipses, then we did hyperbolas, and then we finally did parabolas. Well, when you're taking a standardized test, or next year in pre-calc if you take it, or in college algebra, or more importantly, the last 10 questions of the ACT test, they do throw in one or two or even three conic section type questions. And of course, they're going to be all mixed up together, and you've got to recognize each one as you see them. So we're going to end the chapter today, and then one more small exercise tomorrow with the title Mixture of Conics. And we're going to do a different conic section in each block and see if you can recognize which one's which. And of course, remember, how do I graph that one? Because, we didn't do this since last week. All right, let's look at the first two real quick. The first one says 5 parentheses x plus 1 squared plus 5y squared equals 20. The second one has a 4 and then an x minus 3 squared plus 9 times y plus 1 squared equals 36. They both have plus signs in the middle, don't they? The big difference between these two is in the first block, we have a 5 out in front and another 5 in front. So the coefficients are the same. Whereas here, we've got a 4 and a 9, and the coefficients are different. Okay? First of all, if you look at number 3, there's a minus sign in the middle. Remember, the only conic section that had a minus in the middle was a hyperbola. So that one's definitely a hyperbola. And in the last block, we've only got one letter squared and the other letters not squared. Remember, that was unique to a parabola. So it's pretty obvious these first two, we've got a circle and an ellipse. But how do you know which one's which? Well, the rule is simple. If the coefficient is the same, it's a circle. If your coefficients are different, it's a ellipse. Okay? So here we go. On the circle problem, if you remember way back to probably last Monday or Tuesday when we did circles, if they both had a coefficient that was the same, we really did not want those coefficients to be there. So do you agree we're going to divide both sides by 5 to get rid of those coefficients of 5? We want all the 5s on the left side to disappear and be gone. So if all those 5s are gone, what's that leave me with? X plus 1 squared plus then what? Y squared equals, of course, 20 divided by 5 gives you 4. I successfully got this circle into standard form. So let's review. This is really a good way to end the chapter, to make sure you got all this conic section and can remember to draw the individual pictures. If I'm going to draw a circle, I need to know where the center's at, don't I? And on this one, the opposite of x plus 1 is minus 1. And since it's good old y squared, but it doesn't have a number attached to it, do you agree that the center is negative 1, 0 on this circle? So let's go left 1 and up 0. Negative 1, 0 right there is CR, the center of my circle. And then remember, to draw a nice perfect circle, you got to know how big its radius is. Oh, if this is equal to 4, the square root of 4 is what? Do you agree my radius is 2? So guys, go to the center, go right 2, go left 2, go up 2, and go down 2. And we should have a nice, neat, beautiful circle that looks like that. Okay? So when the coefficients were the same, it was a circle. Looking at number 2, if the coefficients are different, it's an ellipse. Agreed? Now this time, don't divide by 4. Don't divide by 9. Remember the rule on an ellipse. Okay, think with me. Listen to me here. Stay with me. All ellipses are in standard form when they're equal to what? Oh, remember they have to equal 1, don't they? So that 36 needs to turn into a 1. We're going to divide both sides by 36. That makes sense. You got to think of a logical first step to get your problem into standard form. So on the right side, we've certainly got a 1, right? 36 over 36 is 1. Over here on the left side, some of you still got to concentrate better when you reduce fractions. This is 4 over 36. Won't that 4 cancel and the 36 will become a 9? So it's x minus 3 squared over 9 plus, then the second fraction, the 9 will cancel and the 36 will become a what? A 4, won't it? So we get y plus 1 squared over 4 equals 1. That ellipse is now in standard form when I go to draw my oval shape. Where's the center at? Well, what's the opposite of x minus 3? That would be what? 3, agreed? And then since it says y plus 1, the opposite of plus 1 is minus 1. So I'm actually going to go right 3, down 1. There's the center of my ellipse. And then remember how to draw an ellipse. Since the x value has a 9 under it, the square root of 9 is what? 3. So we're going to go to the center and go right 3, left 3. The y has a 4 under it, so I'm going to go, what? Square root of 4 is 2, and since the y-axis runs up and down, I'm actually going to go, what? Up 2 from the center and down 2. And it's an ellipse elongated from left to right. Okay, so we've reviewed circles. We've reviewed ellipses. We have a mixture of conics here. So now, of course, I'm going to go to block 3, the one that has a minus sign in the middle, telling me it's a hyperbola. And your first thought, just like on ellipses, is all hyperbolas have to equal 1, don't they? So again, we need to turn the number to the right into a 1. So we're going to divide everything by 16. So we do indeed get a 1 on the right side, agreed? And on the left, we're going to reduce 2 fractions again. The first fraction is 4 over 16. So what? The 4 cancels and the 16 becomes a 4. So I've got x squared over 4 minus... Now look here, this parentheses understood to have a 1 in front of it, isn't it? So there's really no cross-canceling to do. You're going to leave it y plus 2 squared over, and what number will remain on bottom? 16. Okay, so concentrate when you get your conic section into standard form. Graphing this hyperbola. This goes back to Thursday's notes. Careful, if I said, where's the center? Good old x squared doesn't have a number with it, does it? So my x coordinate's 0, and the y has a plus 2. The opposite of plus 2 is minus 2. So the center of this hyperbola is 0, negative 2. I'm going to go down 2 and put a dot, right? 0 and down 2. There's the center. The x squared has a 4 under it. The square root of 4 is 2. So you're going to go to the center and go right 2, left 2. The y coordinate has a 16 under it, and that's what? The square root of 16 is 4. So you go up and down, go to the center. You're going to go up 4, and down. 4. Now remember, don't connect them up and make an oval shape. This is a hyperbola. So you're going to make a corner, a corner, a corner, and a corner. Imaginary diagonal line, imaginary diagonal line. This is good review. I'm glad we're doing this. Now, how do you know which way to open up your hyperbola? Think, what was the rule? Oh, whichever letter was first told you which direction to draw it, right? If it was x squared first, it opened left and right along the x-axis. So this one's going to be really wide because remember, it's got to get close to the dotted line, but never touch it. If the y squared is first, like might happen on your homework maybe, it would go up and down instead of left and right. That's the only difference, okay? Finally, we've got what? A parabola in the last block. You agree it's a parabola because there's one letter squared and the other letter's not squared. And we just did this on Friday, so let's think. Remember, instead of the center, we're going to find the vertex. But we don't find the vertex till we first decide which direction it's opening. Remember that? What was the rule? When the x was squared, it opened either up or down. If the y is squared, like this one, oh, it opens either right or left. And because 24 is but wait a minute. Yes, 24 is a positive number, so this is indeed going to open to the right. But remember, we always wanted the squared term to be by itself. So technically on this problem, you need to divide both sides by 6 before you start graphing it, because it's in standard form when the squared value is the only thing on the left side. So the 6's will cancel. I'll get y plus 1 squared equals what? 4x. So now we're back to thinking what? Since the y is squared, it opens either right or left, and since 4 is a positive number, it opens to the right. The vertex is at where? Careful. Guys, here's my x, and there's the y. Your vertex is always an x comma and a y ordered pair, since the x doesn't have a number attached to it, like x minus 1 or x plus 3. My x coordinate's 0, and the y has a plus 1 next to it, making the y coordinate negative 1. So when I go and start drawing my parabola, I've got a vertex at right 0 and down 1. This parabola, I'm picturing it opening to the right. So I'll put little v for vertex off to the left. And remember, we always took 4p every time and set it equal to whatever this number was. In this case, 4. So obviously dividing by 4p equals 1. Guys, I'm going to go right. Oh, wait. Remember follow the bouncing pen trick? I got a point 1 inch to the right of the vertex. I've got a point 1 unit to the right of the vertex. So I go right 1. There's my important point. There's an imaginary line going through that point. That's how long. It's a long length of 4 total. So do you agree I go to that point and would go up 2 and down 2? That way the imaginary line I was envisioning was 4 inches wide, and now I know how wide to draw my parabola. Okay? So guys, just as a great exercise to end this part of the unit, the title is Mixture of Conics. I did a circle, an ellipse, a hyperbola, and a parabola, all mixed up on the same day, just to make sure you can recognize them and keep things separate. Again, as if you were taking an ACT test, okay? You'll get into a lot more depth on this topic next year. All right, today is April 20th, Monday the 20th. So your homework, you're going to try a mixture of 4 problems on your own. This would be due hopefully later today. That'd be great. But at the worst case scenario, guys, you got to keep up with the work. This is Monday the 20th. This assignment is due by noon on Tuesday the 21st. Okay? I've got 111 kids to keep track of and put grades in my grade book and check all these emails and grade these papers. I need things done on a timely manner. We're doing this on my schedule, not yours. It's only a 20-minute video and a 5-minute homework assignment. That's not too much to ask for one day, okay? So please, guys, these 4 problems, I am going to tell you it's in a circle, then an ellipse, then a hyperbola, then a parabola. They closely mimic the 4 questions I did on the front, and those 4 problems are due tomorrow. So hit the pause button, copy them down, take your time, put them into standard form, draw your 4 conic sections, shoot me a picture of that by tomorrow, Tuesday at noon. And then we'll finish our chapter tomorrow with what's called systems of conics and end things with one more pretty important topic that wraps this all up as you head into next year with these conic sections, okay? Great job. See you tomorrow.